Hello, everyone. My name is Shannon Prather, the Marketing Coordinator at GIS Inc. I'll be your moderator today. I'd like to thank you for joining us for today's webinar entitled Indoor Positioning Systems and GeoIoT. This is the third in a series of 5 webinars titled GeoIoT, Where Matters. I'd like to take a moment to bring to everyone's attention that if you're planning to join us for any additional webinars in this series, please register for the ones you would wish to attend individually. You will not be automatically registered for all of the webinars in this series. In today's webinar, we'll discuss what it means to be able to track a person or an asset's position indoors. We'll define what indoor positioning systems are, what from a technology standpoint is required, and demo a variety of options out there in the market today. We'll showcase our corporate demo station that's equipped with a variety of sensors, explore popular use cases throughout the industry, and discuss the implications of having this data and the potential for the analysis thereof. Our speaker will also show a demo of Esri's ArcGIS Indoors as a component to complete your overall GeoIoT indoor positioning system plan. Finally, we'll wrap up with any questions your organizations will need to answer before you can get started with indoor positioning system of your own. During the webinar, we'll pause for a moment to ask 2 polling questions to get a pulse on the audience's priorities. I'd like to encourage you to answer those polling questions and additionally post questions of your own in the sidebar throughout the webinar. We'll respond to all questions at the end as time allows. After we answer those questions and provide some closing statements, there will be a brief survey. The survey will show up on the screen after I've finished speaking. We realize you'll want to get back to your day, but please do not hit the close button until you have answered the survey questions that appear on your screen. We greatly appreciate your time. This webinar is being recorded and will be posted online, and you'll receive a link to the recording via email within a week. Before we begin, I'd like to take a minute to advertise the upcoming episodes in the series. The previous episodes you see on the screen, what is GeoIoT, where does it matter? Work Smarter with Sensor Networks, GeoIoT Asset Tracking Analytics have all been pre-recorded and are available on demand. Today's episode, of course, is the Indoor Positioning Systems and GeoIoT. And we've actually merged our episodes 5 and 6. If you guys have been following us on the series, we'll be combining our GeoIoT ecosystem with the future of GeoIoT, Where It Matters. That upcoming webinar will be on November 15th as previously advertised. So let's talk a little bit about GIS Inc. before we get started. GIS Inc. has solved where problems geospatially for over 27 years. With 160 professionals and one core purpose to create insight through location technology, we help state and local and federal governments, as well as commercial industries, to help improve operational efficiencies, increase citizen engagement, optimize investments in the Esri's ArcGIS platform, and increase revenues. Over the past few years, we've paired that location geospatial GIS lens with IoT technology. And without any further delay, I'm excited to welcome our 2 presenters today. Steve Mulberry, Senior Enterprise Architect and Sales Engineer at GIS Inc., and Chris Blakely, our Senior Solution Engineer at GIS Inc. And today, Steve with GIS Inc. is going to get us started. We hope you enjoy the webinar.
Okay, thank you, Shannon. So today's webinar is going to be focused on indoor positioning systems, as we mentioned earlier, and looking at the different technologies and how we might leverage these technologies within our indoor space. So today we're going to talk about and do a quick recap of the 3 sort of technologies that we talked about earlier. Now, I want to go through this fairly quickly for those that have sat through these previous webinars, so we get right to the meat of the topic for today. But I think it's important for those that are joining us for the first time to set some context, because each one of these topics that we talked about previously fall right into line with as we move indoors and using indoor positioning systems. So we'll do a quick recap. We'll get into the indoor positioning systems technology and go into depth talking about that component. And then we really want to spend the bulk of our time actually showing you some technology demonstrations. We've set up a nice demonstration lab in our corporate office in Birmingham, Alabama. So we want to show you how these technologies work. Now, it's always fun to do live demos on a webinar, but Chris and I are up for it, and we hope to show you some really neat things, and then round it off with ArcGIS Indoors and how that plays into the discussion for anything and all things indoors. So let's do a quick recap. So when we talk about IoT, we have to kind of set the stage and understand what these Internet of Things really are. And in a nutshell, they're a network of physical objects that have enough electronics built into them that allow these things to collect and exchange data. And these things can range from all sorts and sizes and types of tags or devices or objects, right? Things that we wear, things that we take with us, our phones and our smart watches, tags that we put on our assets or devices or our vehicles or the gaming systems or lighting or the things that we put into our homes. You know, there's Internet of Things surfacing all over the place. And where this is interesting to us, we get real excited about when we can assign a spatial location or a geographic location to that Internet of Thing, that object, right? Once we can attach a location to it, then we can start to do other type of spatial analysis or analytics, proximity, association. We can really start getting to the meat of spatially awareness of these Internet of Things. And so we've coined this phrase GeoIoT, which means nothing more than the geospatial representation of this thing, right? This Internet of Things out there. And when we hone in on these things, it's important to know that there's sort of three types of things out there. There's things that collect information and send that on to something else. There's things that receive information and then act on it. And then there's things that do both. And there's this phrase floating out there called smart. You've probably heard of things called smart city and smart cars and smart watches and smartphones and those kinds of things. And that's what it's referring to. It's those things that do both, the things that collect information and send it, and things that receive information and act upon it. But in our world, again, in the GIS space, we are concerned with the data that's coming back and forth from these things. So when we reference smart, we mean data driven, because the data really drives all the action. It's the data that's being collected, it's the data that's being sent, it's the data that's allowing us to react to the environment, to the events that are taking place within our space, which falls right into line to this concept of working smarter. Right? We have sensors out there collecting all kinds of information. That information is being collected and sent to other systems like the ArcGIS platform. And within the platform, then we can visualize and monitor that information. But we can also use that data coming in from these sensors to trigger events inside of our asset management system that may automatically dispatch our field crew or trigger service requests or kick off a work order. And we're seeing this type of integration throughout multiple scenarios like stream gauge monitoring or rainfall monitoring, or looking at the bridge integrity, looking at the temperature of the pavement, the weight of vehicles as they cross over, the vibration of bridges, right? Helping us gather information from these sensors, these sensor-based things that's collecting information and sending them on to something else. A lot of citizen engagement devices and sensors are being used, especially in the waste world, trash container capacity, catch basin, road conditions. There's lots of opportunities to use this sort of sensor-based or Internet of Things concept to help us work smarter in our space. Now we understand that there's systems that have been out there in the space for a long time, like SCADA systems and HVAC systems, and we're not trying to replace those systems, but we can definitely leverage the information that's being collected in those environments and also use that data to trigger off events and activities in other business systems like a work order management system or asset management system. And I know we're just scratching the surface here, right? There's all kinds of things out there and use cases and workflows that we can leverage this type of concept with. But it's pretty easy to get started. You think about it from a three-pillar sort of standpoint here. We first need to identify the sensors and the assets that have sensors associated with them, right? So in our world, right, Internet of Things, if it's spatially aware of itself, that's where we get real excited about it. So we can put these Internet of Things devices or sensors and attach them to assets. We can identify those, and then we integrate that information from those sensors into the platform. the ArcGIS platform. And then from there, it's just a matter of configuring the platform to communicate to your asset management system, right? Or your project management system, or what other business system that you're wanting to integrate with. So think of it from a three-pronged standpoint: identify, integrate, and then configure. And then you start to move into this smart, right, work smarter integration concept, which feeds right into asset tracking and how we can improve the way we track and monitor our assets, both indoors and outdoors. Remember those things, right? They're these electronic devices that collect information, send information, and act upon that information. Well, this could be indoors or outdoors. It could be fixed or mobile. It could be things like monitoring inventory or equipment or people or whatever it might be. And all this information has to communicate over certain protocols, and we're going to talk about those protocols today in depth. But things like Wi-Fi and Bluetooth and cellular and lower WAN networks, and those are the communication protocols that help us push data from these sensors, from these things, to other systems, and allow us to act and react to those situations. In the previous webinar, I showcased a demo where we did an indoor asset tracking, where we looked at things like monitoring the patients or guests that come into this health facility. We looked at employees and devices and equipment. We're able to monitor those assets and activity inside of the space. So today we're going to pick it up from here, and we're going to dive in and say, you know, how did we do that? How do we set up this environment indoors to allow us to track and monitor people, things, devices, equipment, inventory, you know, personnel, all kinds of things that we can monitor indoors. If you didn't get a chance to see this demo, go to the last recording, and I go into depth in this particular demo. So why then is indoor so important to us? Or why does this matter? Interesting enough, the EPA has a study out that shows that we as human beings throughout our lifetime will spend 87% of our time indoors, indoor structures, right? They also say another 6% on top of that is inside vehicles. So literally almost, 93% of our life is inside something, a vehicle or a building, predominantly spaces. And so it becomes very important for us to learn how to leverage this information and become more efficient in how we utilize space, how we get around the space, how we make life a little more easier for those that are inside these structures and spaces. So what is an indoor positioning system? Right? It's nothing more than a system that allows us to locate objects or people inside a space or a building. Right? It's the technology that gives us the ability to determine that location of an object or a person. And there's lots of technologies out there that help us achieve this goal. There's lighting technology like smart LED lighting. There's radio signals like RFID signals or Bluetooth or Wi-Fi. There's magnetic, there's ultra wideband, there's even acoustic, sound signals that can be used, infrared, sonar, there's laser, there's lots of different technologies that are being used to help achieve this indoor positioning concept, where I can track the location of objects or people inside of a space. And so what I want to do before we start getting into the technology here itself, I want to pause just for a second and ask a quick polling question. So I'm going to turn it back over to Shannon and have Shannon ask you this quick question.
Yeah, absolutely. So our polling question is, do you currently have an indoor positioning system at your business today? Give everyone a few seconds. All right, thank you all for participating. I'm going to close the poll and then we will launch the results.
All right, yeah, I'm curious to see how many of you out there that actually are using them. So what, 14%, this is awesome. It's good to see that folks are using this technology in indoor space, but it also shows that we got a lot of opportunity to look at ways to leverage this technology, or give you some ideas on why and how you could leverage this technology. So thank you, Shannon, for that. So let's dive into the technology. Let's kind of break it down first, and I want to do that from sort of a classification standpoint here. So let's classify this indoor positioning systems, and we do that sort of in two aspects here. Those technologies that are independent of the building structure and space, right, the infrastructure needed, and those that are dependent on infrastructure or technology already in that space. And so if you look at the independent side first, there's a couple technologies out there that don't require any technology or any infrastructure in a building to leverage this indoor positioning system. Things like image-based technology. So in other words, my camera on my phone could be used to analyze a space as I'm walking through it. Some of you may have seen the example of Google Street Maps, where I can actually have the phone out in front of me as I'm walking, and it'll indicate to me where I'm at and where I should go based on what it's looking at, what it's seeing there, right? And so those image-based technologies allow us to do that. You can augment that with some other technology, like putting signs inside the building so it registers those signs when it sees it. But basically, you can get started with just the video, just the images that it's processing. And then there's this concept of dead reckoning, which means just being able to process where you're going by where you've been, right? And determine the direction that you're walking, the speed, where you've been, and using that information and the sensors that are built into your phone, right? The different types of sensors that are there to help us determine your angle, your pitch, your inertia, all those things that we can use just the sensors in the phone to produce a sort of dead reckoning fingerprint of the space. So there are some technologies that are out there that allow you to be independent, having no infrastructure there to begin to use the indoor positioning systems. But there's also a lot of technologies that require some kind of infrastructure. And so those that sort of fall under this category of needed additional infrastructure to make work are things like RFID or ultra wideband or infrared or ultrasonic, things like Zigbee network. And I don't want to get too detailed in some of these, but there's some other ones out there, but these are some of the more commonly used ones, meaning that I would have to install some kind of infrastructure to support this. Wi-Fi or RFID, I would need to have an RFID antenna, right? Ultra wideband, I would have to have those antennas set up in place. Infrared, ultrasonic, those things would require some additional infrastructure in order to be able to use that technology. But there are some technologies that might already exist inside your infrastructure, things like Wi-Fi or cellular or Bluetooth, or even smart LED lighting. Right? Some newer structures are being outfitted with smart LED lighting with sensors already built into them. They just need to be turned on. And so these are some of the technologies that you might be able to utilize without having to incur any more infrastructure cost just to get started in this indoor positioning system, in this space. Okay, so there's some that require additional infrastructure, and there's some that you can probably just piggyback right off of stuff that you already have in place inside your space. But all these technologies sort of work off the same premise, right? I have to determine a location. And so when we think about determining a location, we're all pretty familiar with how GPS works outside, right? We have our GPS in our phone, we bring up our maps and satellites. I get at least 3 satellite signals, and it calculates the time it takes to get the signal back and forth. And through that, I can triangulate or determine my location in my outdoor space. Well, indoors is very similar, but it has some nuances to it, right, and some challenges to it. So on the left, we're seeing sort of the same concept indoors that GPS has outdoors. So if I have an infrastructure like a Wi-Fi network or a Bluetooth network or these types of beacons or nodes or access points that I have in place, I can use those to sort of do this triangulation, or what they call trilaterization indoors, to determine a location of that thing that I want to track or monitor, that cell phone or that Bluetooth tag or that RFID sticker or whatever it is that I want to track. I can get a location out of that by the more signals that I can read and process, versus this concept of proximity. Proximity means I may have one access point, and if the thing I'm trying to track and monitor walks within that proximity space, then it's going to snap me to that node. So although on the right it shows that orange dot out there by the front door, it's picked up my signal, but it's snapped me to the location of the access point or that beacon or that node that's reading that signal from. So there's sort of two concepts here. Do I need a more accurate location, or I just need to know proximity? And so you can see from these two diagrams too that the complexity or the infrastructure needed to support these is different. And so depending on what you want to track, what you want to monitor, will help dictate what kind of infrastructure you need to have in place in order to achieve your goals. Do I need something more exact, or do I need some kind of proximity, right? Do I just need to know, hey, if this thing is in the space or not, fine. But do I need to know exactly where it is in this space? Then I need to implement a technology to achieve that. So I want to kind of walk through this scenario. You know, most of us use cell phones, and cell phones is probably the predominant Internet of Thing out there, right? And I know some people might argue with that, but the cell phone has over 20 sensors built into it that's collecting information. I can send that information back to some place, some processing server, and I can receive information and act upon it. So how does that work inside of an indoor positioning system? So let's start with the cell phone. A cell phone communicates and listens to Wi-Fi access points out there through this thing called RSSI, which is Real Signal Strength Indicator. So your phone is listening to connect to access points, and the access points are listening to devices that are Wi-Fi enabled. That signal can be picked up and can be used to either define your location by having 3 or more access points pick up that signal, or do a proximity location with at least having 1 access point pick up that signal. So the phone is sending out or listening to signals, the access points pick up those signals. I can triangulate that to get a location or do proximity. Then I can pass that signal down, typically to a base station. Most systems have some kind of base station or server that processes that information. Then I can push that information over to the platform, and then I can produce my end-use solutions like my phone devices or web applications and things like that. So this sort of workflow breaks down into 3 sort of categories. We have our indoor positioning system. In this case, we're doing Wi-Fi. So we have a Wi-Fi device, we have our access points, we have a base station to process the information, the platform to receive it and map it and analyze it, and then the solutions to interact with it. Now, what's interesting that we're seeing here is that moment where we calculate the location, right? That moment where we take that signal and determine exactly the location can happen at different locations. So this, but the process has to happen. I have to determine a location at some point in time. Well, we can do that right on the phone by putting some software on the phone and grabbing those signals and doing the location analysis right there, or we can do it at the edge location right here at the access points, or we can do it back at the base station. But at some point, we got to take those signals and use those signals to locate that device that we're tracking, and then push that down to the platform so we can then use it, see it, and analyze it. Okay, so when we think about things like Wi-Fi or Bluetooth or RFID or those radio signal-based systems, they all work the same way, the same concept. What doesn't work the same way is smart LED lighting, right? VLC, visual light communication. So let's look at this one independently. So your phone, all smartphones have a camera. And if that camera is out, it can pick up the unique signals that are coming down from your smart LED lighting. And that technology can be used to determine your location very quickly and very accurately. So instead of an RSSI signal, radio signal, it's using the lighting signal coming out of the smart LED lighting to determine your location. But then everything else at that point is the same. I take that information, I pass it down, I use it, store it, and analyze it. The big differentiator between the radio signal processing and VLC or smart LED lighting is the accuracy. So when using smart LED lighting in the VLC concept, you can achieve up to 1 degree of directional accuracy, and 6-inch or better. We've seen some down to 3-inch positional accuracy, which is huge inside of certain circumstances like retail space or maybe hospital or healthcare facilities when we need that kind of accuracy. But there are some challenges to that, and we'll walk through that here later when we actually show you some of these technologies. I wanted to throw this screen up here because I want to kind of give you a quick glance at the different positioning types, right? Their accuracy, the latency, the range, the power. This will all be part of the recording. You can go back and review this, but you can kind of see some of those numbers that might help dictate what technology I put in place inside of my facility in order to achieve my goals. So let's kind of back up and do a holistic view again, right? So we've got sensors out there. These sensors are communicating over some kind of communication protocol, whether it's VLC, the Bluetooth, the RFID, Wi-Fi, again, all those other ones that we talked about. The trick is getting all that information into the platform. And traditionally, we use the GeoIoT server role to get the data into that platform. And out of the box, GeoIoT is equipped with a lot of these things called input connectors that connect directly to these communication protocols and ingest this data automatically. But in some cases, there's not. And so what we've done at GIS Inc. is created this bridge that we put in between the many different types of sensors or technology that you want to put in place, because we don't believe that there's one technology that fits all needs. You might have a hybrid approach. You might have Wi-Fi to a certain point, and then Bluetooth kicks in, and then VLC kicks in, right? And that's okay. And so what we can do is we can aggregate all that information down to this bridge, filter out the noise, right? Get rid of things we don't want to track and monitor, the noise out there, and then push that into the platform through GeoIoT. And now we have the ability to map and analyze the information. So that's sort of the technical approach here, right? Understanding what the indoor positioning systems are, how they work, some of the technology behind them. Now I want to introduce our demo center that we have up in place in our Birmingham office. We've been, over the years, putting in place different technologies that we've been testing out to help guide our customers along the path of determining what's best for their space. And so we've got things like AccuWare's environment doing Wi-Fi indoor positioning. We've got BlueLoke's Bluetooth solution for doing indoor space, doing Bluetooth tags and Bluetooth beacons. And we've got RFControls technology inside the Birmingham office doing RFID indoor positioning systems. We also are using AccuWare's camera tracking technology to kind of do to kind of bring it all together. And each one of these has its pros and cons depending on, again, the type of solution that you're trying to put in place to solve the problems that you wanted to answer inside of your facility. So I want to show you this now. So we're going to spend the next 20 minutes or so just showing you some of this technology. So what I'm going to do is I'm going to introduce Chris Blakely, who's going to kind of walk us through this process here.
Okay, thanks, Steve. Steve mentioned before the getting to do the live demo, so we'll find out today how well this is going to go. But what we're going to show you are a few different of the types of indoor positioning systems that we have deployed in our home office in Birmingham. And as Steve said, none of these, there's not really any silver bullet perfect system. They've all got their pros and their cons, and we're using our facility here to test out, work with hardware partners, write our software bridges that pull positioning data out of these systems and put them into the platform. So what Steve's showing you here is AccuWare's Wi-Fi location monitor. And these dots that you see on the map, that's a floor plan of our Birmingham office. The dots are Wi-Fi access points or nodes that we've deployed along the ceiling in the office. And these are open mesh nodes that AccuWare's system works with, and they all mesh together over Wi-Fi and are able to then do that trilateralization that Steve mentioned before. You'll see that some of these are red. We've been having an issue, I think, with one of our Ethernet switches in the office, and if they're not polling online, they'll turn red like that. So again, the beauty of the live demo there, that one hasn't been seen in 2 days. So when all is working properly, when they're all connected, they'll all show green, and that gives you a visual indication of what it is that's detecting the ambient signals. It's this grid pattern of sensors, which are just doing nothing but sitting and listening for Wi-Fi signals that they see. And when they then receive those signals, they transmit them to the AccuWare cloud service, and AccuWare does the trilateralization of the signals. So if a single device is seen by 5 nodes at the same time, it'll use the varying signal strengths of each of those to do a calculation to put a position down on the map. Now, one of the benefits of Wi-Fi is that Wi-Fi allows us to anonymously detect any Wi-Fi signal in the venue, and that would include everything from laptop computers to smart TVs to smartphones that people are carrying on them. As long as it's pinging to see what networks are available, the AccuAir system can see them and position them. It's good because it lets us see a lot of stuff that the other technologies might not let us see, but it's also very noisy, and Wi-Fi is sort of the least accurate of the positioning methods. So Steve, if you'll turn on the all known, go ahead and turn up the node labels and turn on all known devices. We're able to go in and register known MAC IDs with the system. So we've got Kevin Stewart's iPhone is registered, and we've got a Nito robotic vacuum that's registered. Those are the two dots you see, and that's where AccuAir is currently calculating that their positions are located. Now, I'll say Kevin may not be there, and having those 5 nodes offline right now will skew the calculations a bit, but I think it makes the point that we can name individuals and track them individually, search for them and whatnot. But Steve, if you go ahead and turn on all devices and turn off the labels, you'll see that it's not just those 2 devices that it's seeing all of these things. And if you ID on or click on a couple of those, Steve, to kind of show what they are, this is a device with a MAC ID that was seen 1 second ago. That one was seen 7 minutes ago, and it'll track these over time and put points on the map. So a couple of things about this. One, this is the raw data. So this is every single Wi-Fi signal that is seen by the AccuAir system right now. And 2, you can see some of the limitations with the accuracy. So these things that are way out in the parking lot, those are probably artifacts of the positioning algorithms not being very accurate for those. What we can do with this raw data then is we can filter it both via geofences, so we can say we don't want to accept any positions that are reading as outside the building, and we can also run it through a series of filters to do things like filter out devices which we know aren't smartphones. If all we're here wanting to track are smartphones, we can filter out many of the things that we know are not. We can do other kinds of time-based filters and whatnot to take this raw, accurate positional data and then put it into the ArcGIS platform. So the GeoIoT bridge that Steve mentioned before takes those positions straight out of AccuAir via their API and runs our spatial filters and all of these other types of filters on the data before pushing it into GeoEvent. And so what Steve's showing here is a ArcGIS online map that's got the filter down setup points. So now we're just seeing things that are within the boundary of the office and just things which meet the criteria that we're filtering for. And we can filter in all types of different ways. And we get all the benefits of having the ArcGIS platform with heat maps and historical tracking and things like that. So Steve, if you can go back to the AccuAir dashboard. So this was the Wi-Fi location monitor. Again, the benefit being that you can track anything with Wi-Fi and get a lot of data, but it's also sort of the least accurate of the tracking technologies. So Steve, if you'll switch the site to the Bluetooth site, we'll show you AccuAir's Bluetooth beacon tracker, which works in basically the same exact way, except instead of using Wi-Fi nodes, this uses Bluetooth detectors, which are the same concept. These are mounted actually side by side with the Wi-Fi nodes, and all they do is sit and listen for ambient Bluetooth signals. In AccuAir's case, it's iBeacon protocols. So when we have iBeacons moving around in the office, it does the same calculation. These nodes can read the signal strength of the Bluetooth beacons they see, do the trilateration, and provide an output for us. We've done the same thing with just the Nito vacuum here. Steve, if you turn on all known, you'll see down there in the bottom right-hand corner, that's our break room in the office, and the Nito vacuum is showing up right there in the corner, which corresponds, Steve brought up the live view camera of the break room. It corresponds to the space right between those 2 plush chairs along the back left wall. There's a table there, and the vacuum is parked in its base station underneath that table. Just real quick as well, we also have iBeacons scattered throughout the office. Some are on people and equipment and whatnot. Steve, if you hit all devices there, we'll kind of show what that looks like. And again, just to drive home the point, the big difference here is that we're not tracking anonymously. Each of those is a Bluetooth beacon that's in the office that we've had to affix to a person or a piece of equipment. So these are they're opting in to being tracked just by virtue of the fact that they have an iBeacon on them. Whereas with the Wi-Fi technology, we're tracking just everything it can see. And from that, one of the neat things about the demo center is we've got this robotic vacuum that Steve can go ahead and kick off. If you hit start there, this vacuum is one of these robotic vacuums that you might have in your house. We've got it there in the break room, and we have strapped beacons on it. So it's got loaded on it two different types of Bluetooth beacons, one as an iBeacon for the AccuWare system, one is a proprietary beacon for the BlueLoc system, which we'll show you in a minute. It's got a Wi-Fi tag built on it, and it's also got an RFID tag on it. It looks like he peeked out there for a second, but he should be coming out, and you'll notice that the dot has started moving, the dot for the vacuum on the AccuWare side, showing that it is indeed moving. Now for Bluetooth, we tend to get between 1 and 3 meters accuracy, so you'll see it moving, and you'll generally know which room it's in, but you wouldn't be able to precision target it. Depending on the different circumstances and the density of your detection grid, you can do better or worse with that positioning. So from there, Steve, if you'll jump over and bring up the BlueLoc dashboard. BlueLoc is another indoor positioning company. They only do Bluetooth. They use a different type of node and a different type of beacon, but conceptually it's the same idea. It's a detection grid of sensors, which will then detect tagged assets that have got these special tags on them. So if you pull down, Steve, the display there and show the beacons, this will give you the positions of the beacons. That BlueLoc calls them beacons. We generally call them nodes for all systems, but these are the things that detect the Bluetooth beacons. And if you then pull down the display again, Steve, and turn on the base station, all the AccuWare systems talk directly to the internet with their own connection. In BlueLoc, they all talk through a base station, which they're centrally located in one of the conference rooms. So that acts as the gateway to the internet for these standalone nodes or beacons. And then, Steve, if you'll turn that off and go ahead and turn on, did it not go off? There we go. Yeah, turn on walls. One of the advantages of the BlueLoc system is they support barriers and obstructions and walls. So we can go in and draw on the base map areas that we're going to say is physically impossible for an asset to move through. So these walls, as the BlueLoc system does their calculations, it knows that it's an illegal move to let a point go through a wall, so it won't allow that to happen based on its logic. And then lastly, Steve, if you'll go ahead and yeah, there's obstacles as well, things like chairs and tables that we know that it can't move through that are different than walls. And then Steve, if you'll go ahead and turn on the tag, that robotic vacuum has got, as I said, a Bluetooth tag on it. Steve may actually be able to zoom in if it comes back into view and kind of show you what the tag looks like. But you'll see there on the BlueLoc dashboard on the right, you'll see 2 dots with ellipses around it. And what that's showing is a real-time position where this is where BlueLoc thinks that device is right this second with a buffer around it of uncertainty. And then it shows a delayed position with a smaller buffer of certainty. And what happens is that the BlueLoc system does some predictive calculations where which direction it thinks it's moving and which direction it's going to be in the next couple of seconds. That's the real-time view. If you're willing to wait a few seconds for the delayed view, you can get a more accurate position of where it actually was versus where it thought it was in real time. Both of these positions are available via API. We can pull them out and use either one. And again, with any of these technologies, we can actively pull the position information out of the whatever partner we're using and pull it through our GeoIoT bridge and push it into the ArcGIS platform. And those are the technologies I am going to demo. Steve, I believe, is going to transition back and start talking about the RFID technology.
Excellent, thanks, Chris. It's always fun to show and see things live when they work, and it seemed to work out fairly well there. Great uses of the technology, and again, as Chris mentioned, we don't really care, and I don't say care, but that's maybe a hard word, but we don't really care about the type of sensors or the communication protocol that you may determine is best for you. But what we really care about is getting that information into the platform so that you can then use your investment in the ArcGIS platform to do the mapping and analysis and push out solutions to the end users. So we want to show two more examples. These are a little bit harder to show live, so we're going to do a quick video of that. So this next one is from a company called RFControls, and they provide these RFID antennas that allow us to then use the different types of RFID tags, and they could be stickers, and there's literally probably hundreds, if not thousands, of different types of RFID tags out there that you can use. And so we, at the last user conference, Esri's user conference in San Diego, we put one of these antennas, you can see it right there in the middle of our booth. We put one of these antennas up, we put some of these RFID tags on our lanyards, and we started to track and monitor our movement within the space here. RFID itself lends it some unique opportunities and capabilities within a space, just sheerly because of the nature of the technology itself. Meaning the antenna is reaching out and activating and looking for these RFID tags and using information to then determine its location. Now, we said that it's important to have 3 or more of these antennas or access points or beacons to be able to determine location. Well, inside of these RF control antennas are 3 or more built-in antennas. So it has that capability already inside this one piece of device, has multiple antennas in it that allow us to do that triangulation or that trilateralization concept here. So let me show you real quick an example. This is the RFControls interface. Basically very similar to the AccuAir or the Blue Look, where you come in and you define properties and parameters about your site. You set up the site, you set up the area that you're going to monitor, the location processing algorithms that you're going to use, and you set up the actual characteristics of the scan area and the antenna itself. So these are just a series of configuration tools that are used to help configure the system, calibrate the system, use the right processing algorithms and the right technology inside of these systems to get back that location, right? And each one of those, AccuAir, Blue Look, RFControls, and even the Acuity stuff here we're going to show you in a second, will always have some kind of interface to help us define and manage the infrastructure itself, right? Establishing the nodes, establishing the antennas, checking their status, their uptime, their downtime to help us maintain and monitor. In this case, we're setting up zones. So here we set up our antenna and we defined our zones that we want to track, and basically the sort of the center of these zones. And again, this is just helping us establish where the antenna is going to look and how far out. Then we can look at the health, right? Make sure, hey, the antenna is scanning and looking at things. And then we can actually go in and look and monitor the different tags that it's picking up. This could be any RFID tag, right? So the antenna itself is not specifically looking for a specific tag. It's looking for any RFID tag out there within its range of view. And so in this case, here's several tags that the antenna is picking up on, and we can look at, you know, the ID, the zone, the location. In this case, location is in X and Y, Cartesian coordinates, right? And we need to change those later. And then we can look at that from a visual standpoint. So the antenna's right there in the middle. There are the 4 zones we set up. And then these green dots illustrate the location of any of those RFID tags. Again, they could be anything. It was interesting that Dan, who was setting this up and testing out, had some old ski lift tags, RFID tags, and they were hanging in his room, and it picked up those things. So literally any RFID tag can be used within this environment. And then once we, again, get this information, just like AccuWare Blue Look, we take that information, we filter it out, we clean it up, and then we pass that over to the platform that then gives us the ability to visualize that. And we do that through a tool called Node-RED. I just wanted to show this here real quick. We grab the information, do some of our cleanup and calculations just with some straight JavaScript code, not a whole lot here, but once that's in place, then we can bring it right up into the same sort of platform and use the same Esri maps and platforms, then show those tags and those locations of anything that RFID tag is associated with. And what was interesting, as I mentioned, Dan was kind of working through this demo. He kept seeing this one rogue RFID tag that he couldn't determine where this was coming from. So he grabbed the ID and he went out. He has this antenna actually in his garage, and he started searching his garage trying to find this RFID tag. And it ended up being that his recycling bin provided by his company has embedded RFID tag inside the recycling bin. So you can see the ID number there correlates to the ID staple there on the recycling bin. So you never know what you're going to find out when dealing with RFID tags, which is a fun experiment there. And then finally, the smart LED lighting. So remember, in this scenario, the camera needs to be, the phone, this is an application that runs on a smartphone. The camera needs to be out and positioned so that the camera can pick up the lights coming down from the smart LED lighting. And I'm going to start playing the video over to the right. You'll see up here in the upper right-hand corner, we have Sonny from Acuity who's holding his phone, and you can see the 1 degree of directional accuracy. So as he turns his phone and starts to move or walk, it'll get very accurate. So in this case, he's going to create a shopping list, get a shopping list ready to go, and then the application will, give me, the quickest route to each one of these items that I need to pick up. And you'll see Sonny back in the back starting to move across the back part of the store here. When I get to a certain place, the application can then use proximity then to maybe push coupons out to the individual as they're walking through. I pick my item up, it goes off the list, start making my way down to the next item, and you can kind of see Sonny making his way up here. But the concept again is using the lights and the sensors built into the light to determine my almost exact location, 1 degree of direction on 6-inch or better positional, to help me get around a space. And what's interesting, you'll see here in a second, is that when Sonny's done picking up his item, he puts his phone in his pocket. So you can see that cone now of accuracy changes to Bluetooth. So it automatically went from VLC to Bluetooth. And you can set up these hybrid solutions to do just that, to get you around your space there. So how does all this play into ArcGIS Indoors? So let's talk about that for a second. So we've got these different technologies that provide us that blue dot, that give us that ability to determine a location of something, right? A tag, a person, an object, a thing, equipment, device, whatever we're trying to track indoors. Well, ArcGIS Indoors is a solution that Esri is building to help enhance the use of that blue dot, right? It runs on top of the platform, doesn't matter if it's online or enterprise, but it provides us with a series of components. The first component is what they're calling Indoors for Desktop. So it's going to be a set of ArcGIS Pro tools that allow me to build the infrastructure needed to support my indoor mapping, right? So it's going to be an information model that allows me to build my floor plan and build my network and set up my POIs and just set up my indoor space from a mapping perspective, right? Get that data ready to go so that I can use it within the other applications, like the Indoors Mobile. The Indoors Mobile will be an application that runs on mobile devices, allow you to do things like wayfinding and navigation. We'll incorporate the indoor positioning system that you configure, so it'll show you that blue dot, right? It'll allow you to integrate your day-to-day workflow. So maybe you want to tie in there asset tracking or doing workforce type of management tools. Find me get me from where I'm at now to my 5 work orders that I have to accomplish for the day, right? Integrate that kind of business logic into the application. And then the third component is Indoors for web. So it's going to be a series of 3D responsive web applications, potentially a dashboard that kind of gives us an overall operational view of what's happening within the space. But think of Indoors as these components: desktop, mobile, and web. Desktop giving me tools to create and manage my information. Mobile to allow me to do wayfinding, navigation, and workforce type management solutions out in the space. And then web-based tools to give me an overarching picture of what's happening within the space here. But the key is that all this will be able to tie directly into whatever indoor positioning system that you provide or you set up within your space. Now, out of the box, Esri is going to support some of the big boys out there, like Acuity brands, which I just showed you with the smart LED lighting. Google and Apple with their beaconing and dead reckoning technology. Then Cisco and Aruba with their Wi-Fi network. So those are the ones that will be supported when Indoors gets released in 2019. For everything else, there's us, right? And I say that with all the confidence that we've been spending years looking at this technology and finding out what works best in space, right? So we've settled on things like AccuAir and BlueLoc and RFControls, and we have some others that we'll introduce in our next webinar when we talk about our ecosystem of technologies. We've done the work. We've gone through the battle pains and the wounds of finding out what works best in solutions. So leverage us for that knowledge, right? Let us help you determine what works best inside of your space. And so let's take a quick look at ArcGIS Indoors. I wanted to just show you a quick example of how this works. So we're going to come over here to the indoor space. This is a solution that Esri put up for the UC. So this is the San Diego Conference Center, and I can run this on my smartphone or within a web-based dashboard like you're seeing here. But I can do things like do wayfinding. Let's find a certain spot. So let's go out and find the GIS Inc. booth where it was located in my space out there. So let's find that. And again, I can build sort of this directional a list of things that I want to go visit. So I found my space there. I'm going to do directions. And since I'm indoors, I want to do not driving, I want to do walking, and then find where I want to go. And let's pick one of the sessions on indoors. So we'll just search for indoors, and this is how it would work on your phone, right? That mobile component will allow you to very interactively pick through the information that you assign to your space. And once I've determined where I want to go, I've got this nice map that gives me my directions, and then my blue dot as I walked would keep me on the path to get to that space. But what's interesting here too is we work in a 2D space forever, but we need to start leveraging 3D, and the technology and the platform gives us the ability to immediately switch from 2D to 3D. And I can see that information here, and I can realize, oh, I've got to go down some stairs. I may not want to do that. So let's readjust my route and avoid any stairs. And because of the network that I built within the desktop tools, I can provide that capability and function to the end users through the mobile application. So look for ArcGIS Indoors in 2019. Esri introduced this at the UC conference, had a lot of sessions on it, so it's getting a lot of traction. There's going to be tools, mobile apps, and web solutions part of this release here. So let's kind of sum up here and kind of talk about what we've just seen. So again, why does Indoors really matter? Well, if you start looking at the different capabilities out there through wayfinding, through navigation, there's security issues that we can use here. There's location-based services like pushing coupon notifications or helping individuals navigate around a space. Obviously, the asset tracking, workforce solutions, retail analytics, looking at healthcare and hospitals. Manufacturing is a big play in this space here, looking at airports, campuses, sporting events. I mean, I could go on and on and on with the different types of use cases or workflows, excuse me, that we could use this technology in. So this could be kind of inundating with a lot of information. So how do we get started? Where do we at, or what kind of questions do we ask, and how do we get started in this space? We've come up with these sort of starting questions here. What are we trying to monitor? Is wayfinding needed? Right? Do we have to have that blue dot? Is navigation required? What level of positional accuracy do we need? Right? Do we need that VLC level? Can we deal with something a little bit relative, Bluetooth or Wi-Fi? Do we need something a lot better than that? How often do I need that signal? What can my facility support now? We talked about the required infrastructure or the non-required infrastructure, right? And then security. Security is always a big question around what's necessary to make this information available to others. So with all that information that I just kind of laid out here over the last 50 minutes or so, let's have one last polling question before we kind of sum up with some questions. So Shannon, I want you to go ahead and hit us with that.
Yeah, so now that you've learned some different applications with indoor positioning systems, are you interested in adopting one?
So remember, think about the different types. We had Wi-Fi and Bluetooth and RFID technologies. There's even things we weren't able to kind of show in depth, like the ultra wideband, which is a more acceptable protocol coming out, the smart LED lighting. There's lots of different options out there.
Absolutely. All right, we'll go ahead and close. Thank you so much for those who voted.
All right, let's see what are our responses there, Shannon? Interesting. All right, good. So there's lots of opportunity. I know this isn't the first time you've probably heard about this, and you've been already probably thinking about it and trying to create some plans and some ideas. Again, leverage us. We've been doing this for years. We've got a lot of battle wounds, and we can help steer you in the right direction. So I guess with that, let's kind of open it up for questions. Shannon, and maybe read off some of the questions that you've kind of seen come through, and Chris and I will do our best to answer.
Yeah, absolutely. There was a question about what about magnetic?
Yes, and so magnetic is something that's sort of already built into a lot of our smart devices, and that falls under that sort of independent discussion when dealing with indoor positioning systems. I can use the magnetic sensor capabilities in my phone to do that sort of that dead reckoning, or help support the dead reckoning side of indoor positioning systems. So that's definitely an option.
All right. Are anyone doing indoor positioning systems using Wi-Fi triangulation mapping without beacons?
Without beacons, so you have to have at least an access point, right? So in some of the places we've installed this, where folks didn't have infrastructure, but they had like a Cisco network already in place, or an Aruba network, they didn't have to install any additional beacons, but they did have to leverage the access points associated with that network technology. So Cisco has their access points, Aruba has their access points, right? Use that technology. You didn't have to use any more beaconing for the Wi-Fi. Chris, anything else to add to that?
No, I think that covered it pretty well, Steve.
Right. We've got quite a few questions. We'll try to answer at least one more, and all of these rest of these great questions we'll answer in our follow-up email. So the last one, when using VLC for tracking, how does it work if someone puts their phone in their pocket? Does the location accuracy become worse?
Yes. So if you remember, at the very end of that video, it showed Sonny putting his phone in his pocket. So as soon as you do that, VLC is no longer being used, right? Because the camera can no longer pick up the light from VLC, but it automatically switched over to Bluetooth. So from going to 6-inch accuracy with the VLC, it probably went to the Bluetooth technology, which is maybe 1 to 3 foot accuracy. So you still get some good accuracy with Bluetooth, but you don't get as accurate, but you can do a hybrid approach, so you can switch back and forth. So in reality, I could be starting outside with GPS. As soon as I get closer to my Wi-Fi in the building, pick up Wi-Fi. As soon as I walk into my space, I can switch over to Bluetooth. And then if I pull my phone out, switch over to VLC, all of that can be automatically built into the solution as you go from space to space to space.
That's excellent. And we'll go ahead and wrap up this episode. We're at the top of the hour, and we will be answering all of the remaining questions via email. So all of you on the call will get a copy of those questions and answers. I do want to bring to your attention that there is one more season finale, if you will, Future of GeoIoT and Why Where Matters. That's November 15th at 11 a.m. Please register for that, and there'll be a link to register in our follow-up email that you guys will receive sometime early next week with the recording of this existing webinar episode. Finally, there will be a few short survey questions that will come up on the screen once we finish speaking. We greatly appreciate you taking the time to answer them. Thank you so much for joining us, and please have a great rest of your day.